Hello and welcome to this video for Chemistry 20 in the Stoichiometry unit. In this video, we're going to apply the same stoichiometric steps that we looked at in gravimetric stoichiometry. So that was stoichiometry using masses, but this time we're going to be having solutions. So we're going to start using the formula or adding the formula C equals N over V. Okay, same steps as we did in the mass stoichiometry called gravimetric stoichiometry. So step one, write a balanced equation, including all states. Very important it's balanced, right? Write down all the information given. If you're given masses, calculate molar masses. If you just have concentrations and volumes, you don't have to worry about molar masses, okay? At this point, again, identify your wanted and your given. Okay, the wanted again is the one you want to find. The given is the one you're given the concentration and volume of. Next, you're going to find the moles of your given. Okay, moles of your given are going to be found now with C times V. Unless you have masses again, then you will again find moles with mass over molar mass. So you could be using both formulas in these questions. Okay. Then you're going to apply your mole ratio, like we always do in stoichiometry. Moles wanted equals moles given times wanted over given, okay? Then finally, you're going to find your answer, whatever it is that you're looking for. So you could be looking for mass, which would be moles times molar mass. You could be looking for concentration, which would be N over V. Or you could be looking for volume, which would be N over C. So different formulas depending on what it is that you're looking for. But this is the information of the wanted species that we're looking for in step 4. Okay, so balanced equation, right? Given information, identify wanted or given. Now, and I'm actually going to mention this now, I should have mentioned this in the last video, but there's no such thing as mass wanted equals mass given times wanted over given. That's not a thing. We cannot use that, okay? We can only apply the wanted over given ratio to the mole value, all right? In the solutions unit, we did apply it to concentration, but in this unit, I can't. I can only do that if I have a dissociation equation. We're going to be dealing with our balanced chemical reactions, not a dissociation equation, okay? So you cannot use that formula anymore. Same with dilution. CI/VI equals CF/EF. That's another mistake I see students use in this section. You cannot use that formula. The only time you can use that formula is if you're adding water to a solution. This is a balanced chemical reaction. Okay, so the only thing we can apply the wanted over given to is the moles. So that's why step 2 is always finding the moles with whichever formula we're going to be using based on the information we're given. Okay, let's look at an example. So it says, what volume of 14.8 mole per liter potassium hydroxide is needed to react completely with 1.50 liters of 12.9 mole per liter sulfuric acid? Okay, so sulfuric acid, if you have a Chem 30 data booklet, you have an acid chart that'll actually give you the name and the formula. But if not, you're going to use your acid naming rule system. It ends with ic. It doesn't start with hydro. So that means that this is coming from, using the chart, hydrogen sulfate. Okay? Sulfuric acid is hydrogen sulfate. Now that is acting like an ionic compound, so we do balance ion charges for that, okay? We are given the formula for potassium hydroxide, so that obviously is already balanced. Always check your solubility chart, but if it's telling you that it's a solution, that means it's aqueous, okay? So sulfuric acid would be H2SO4 to make the hydrogens balance with the sulfate. Okay, now this is technically a double replacement reaction. I have two ionic compounds. Acids act like they're ionic. The potassium is then going to switch with the hydrogen. I switch my metals. So potassium will go with sulfate. Now potassium as an ion has a 1+ charge. Sulfate, remember, was 2 negative. So that would be K2SO4. Always balance your compounds individually with their ion charges. And then my hydroxide has a -1 charge. My hydrogen is 1+, so that would make HOH, which is just water. You can write it as H2O, but I like to write it as HOH for my balancing purposes. Okay, so that's step 1, my double replacement or neutralization reaction. Now, I look at my K's. It doesn't matter the order you balance these things in, right? I'll look at my K. I have 1 K on my reactant side, but 2 Ks on my product side. So I need to put a 2 in front of my potassium hydroxide. That now, and I'm going to leave hydroxide as one whole thing. Same with my sulfates. I'm going to leave it as one whole thing. Okay? So on my product side, the hydroxide in the water, there's only 1 hydroxide, but I put a 2 in front of this compound, which gave me 2 hydroxides. So I need to put a 2 in front of here now to also get 2 hydroxides. Now that as well is going to give me 2 of the hydrogens, but if I look over here, I already have 2 hydrogens. Okay? I have 1 sulfate and 1 sulfate, so everything is now balanced, right? So just a little review for balancing reactions. When you have polyatomic ions, leave them as a whole ion unless they're decomposing or splitting up. So I can put 1s there, and now I have my balanced reaction. Okay, so like I said, we're treating this like a chart. These are my headings, so I'm going to split it all up. And now let's write down all the information we have. So we are being asked for the volume of KOH. So that is my wanted. Now I do know the concentration of it. The concentration is 14.8, but I don't know its volume. That's what I am going to be looking for in this question. I am given all of the information I need to find the moles of the sulfuric acid. So the sulfuric acid is my given. I'm given both its concentration and its volume. Those are the 2 things we need to find moles. Okay, so whatever you have all the information of to find the moles of, that is your given. Make sure your volume is in liters. It already is, but if it wasn't, make sure you always convert that. Okay, so there is step 1. My balanced reaction and all of my given information. Step 2 is to now find moles of my given using C times V. That's the concentration formula rearranged for moles. So my concentration was 12.9 moles per liter, and my volume is 1.50 liters. So this liter's at the bottom, it'll cancel with that liter, and we will be left with moles. So moles of my given will be 12.9 times 1.5. So I get 19.35 moles for my given. Now I take it over to my wanted, because the moles of my wanted is the moles of my given that I just found, 19.35 times wanted over given. So in front of my wanted, there's a 2. In front of my given, there's a 1. So the moles of my wanted is 38.7 moles. Okay? Now I'm going to find my final answer, which was looking for volume. So the formula for volume is N over C. Again, the concentration formula rearranged for volume. So my N was 38.7 moles. I'm going to divide by the concentration of my wanted, which is 14.8 moles. I explained this in my last video, but whenever you have the denominator in the denominator of a fraction, it moves up and becomes part of the numerator. So just for unit analysis purposes, we can see how our moles cancel and we're left with liters. Okay, whatever units you're solving for should always be left on the top. So I get an answer for my volume of 2.6148 so on liters. Now I go back up to my question. There's 3 digits, 3 digits, 3 digits, so I can keep 3 digits in my answer. We're cutting off a 4. That's not enough to round the last digit we're keeping up. So my volume stays at 2.61 liters. Okay. Again, common questions I see students ask is, does the 8 round the 4 up and then that becomes a 5? No. Whatever the number is after that doesn't matter. Okay. We are cutting off a 4. That's all that we're looking at. Just the first digit we're cutting off. If it's a 5 or more, it rounds the last digit that we're keeping up. If it's less, 4 or less, it does not round the last digit up. So 2.61 is our answer. So that is solution Stoich. And like I said, there might be masses involved as well, but you're following the same 4 steps. Okay, so a review. Step 1, this was step 1, where I wrote my balanced reaction, I wrote down my given information, I identified my wanted and given. Step 1. Step 2 is right here, where we find the moles of our given, this time using C times V, but if I had mass and molar mass, it would be mass over molar mass. Then this is step 3. Find the moles of our wanted by applying our mole ratio wanted over given. Then this final step here is 4, where I find my final answer, which in this case I was looking for volume, so that would be N over C. Okay? That's it for solution Stoich. Thank you for watching this video.